is an example of a complex fraction because it has more than one fraction. How many fractions do you see there? There are three. I have 1 over A, I have 1 over B, and then I have the fraction for them both. So we have to have just one fraction in the end. And the steps are very clear. What we do is we make one fraction in the top. And we make one fraction in the bottom. In order for me to make one fraction at the top, I have to find common denominators. What is the common denominator going to be here? A. So I'm going to multiply the top and bottom by A. What's the common denominator going to be here? B. So I multiply the top and bottom by B. Notice that in your numerator here, we're left with 1 minus AB. And in the denominator, you're left with A. In this one, we also have a 1 minus AB. And in the denominator, we are left with B. Now it sets up to a problem just like we saw yesterday. We have a fraction over a fraction. And I never divide fractions. What do I do instead? Multiply by the reciprocal. Yep, good. So I take B over 1 minus AB. And when I do that, what do you notice happens? As we look across, we can see that the 1 minus ABs, those will reduce to 1. And we have B over A. B over A. That's the process every time. By the way, I said I'd give a shout out to the robotics team. Robotics team meets Mondays and Wednesdays from 3 to 5. And they have some great members. They would love to have a couple girls on the team. So if you're interested, sign on up. They need you. I'll mention it later on, but be a good activity. I think that Evie said she was not involved in a fall activity. Is that right?
That might change.
I think she said she wasn't involved in a fall activity. So you go, Evie. Just throwing it out there. I don't want to call you out in public or put pressure on you or anything. But all right, here we go. The next one is slightly different. I'm trying to show a variety of examples for you so you can approach them correctly. We have 1 over x, and I have minus 1 over c. But the next part at the bottom, x minus c, both those denominators are 1. So I can write it as x minus c all over 1. X minus c all over 1. Okay? So the bottom is taken care of, the top is not. What's the common denominator going to be in the top? xc. So I will multiply the top and bottom by x. And I'll multiply the top and bottom by c. What do we have in our numerator?
C minus x.
C minus x over cx divided by x minus c over 1. Once I get to that point, it's exactly like we did yesterday. We have c minus x over cx times 1 over x minus c. Are c minus x and x minus c the same? No, they differ by a factor of -1. So if I factor out a -1, then I can cancel them. And notice that you get a -1 over cx. We are not going to do problem number 4. Sometimes people wonder why I cross things off like that. It's because when I first started this job, we had 52 minutes per class. We're down to 43. just the way our schedules worked over the years. So got to get rid of something along the way, and we have a little bit of time to work. So for number 3, what if I wrote the h over 1? And then to get common denominators, notice how I have a 3 plus h, so I'm just going to add h to the top and the bottom.
No.
Thank you. Thank you. I appreciate it. You should be mortified by that. That should really stir up some anger inside of you, okay? Oh, be passionate about it. No, stop it. Mr. Gens, you eat a bowl of stupid for lunch or what? Okay, so the common denominator is going to be 3 times 3 plus h. So I multiply by 3 plus h. In order to do calculus, you must know how to simplify complex fractions. This problem is straight from a calculus problem. Okay, so I'm going to take care here to do this well. I've got 3 times 1 is 3. Then what do I have after that? This is where people make mistakes. What else will I have in the numerator?
Negative 3 minus h.
Negative 3 minus h. What did you do there, Ben?
You multiply. Give me a sec. So it's in parentheses 3 plus h at the top, and then you're subtracting.
He distributed the subtraction sign all the way through. Okay, excellent work. A lot of times people forget to distribute that subtraction sign. That's all over h over 1. Sometimes people right away multiply by the reciprocal, but first I notice that something simplifies here. What do you notice? It's glaring right at you. What can we simplify right now?
3.
The 3 minus the 3 goes away, yeah. So we are left with a negative h over 3 times 3 plus h, and we're going to multiply that by 1 over h. Notice that the h's will divide in this scenario to 1, and so I'm left with negative 1 over 3 times 3 plus h. Not too bad? Okay, we do 2 more problems. There you guys have a ton of work. Number 5 looks bad. It's really not. I have x minus 5 minus 18 over x plus 2. I'm going to write that x minus 5 over 1. That way I can see I need to combine those 2 fractions together. And in the denominator, I have x plus 7 over 1. I add to that 6 over x plus 2. What should be the common denominator in the top?
X plus 2.
X plus 2. So I'm going to multiply the top and bottom by x plus 2. And in the bottom, I will also multiply the top and bottom by x plus 2. So that I have a denominator of x plus 2 as well. So we multiply the top. X times x is x squared. 2 times x and negative 5 times x will make what in the middle? Negative 3x, so says Hannah. And 2 times negative 5 is negative 10. I'm going to go ahead and subtract the 18 as well. Negative 10 and negative 18 make negative 28. So if you were to combine all the like terms in the numerator, that's what you would get. I like to combine things in the numerator. That will sometimes allow for a factoring to take place. In the denominator, I like to leave it in factored form. In this case, we just have our x plus 2. Over, now I look to this denominator. I have x times x is my x squared. I have a 2x and a 7x, which will make 9x. And then I have 2 times 7 plus the 6. 2 times 7 plus the 6. Grand total of 20x And that is all over the new denominator of x plus 2. So by this point, you should be able to kind of predict who can see something that will cancel right away when we multiply by the reciprocal.
X plus 2.
The x plus 2's will go away. If you have the same thing in each denominator, they should cancel, okay? So I multiply by x plus 2 over the x squared plus 9x plus 20. And when we do that, you can see that the x plus 2's do reduce. And you might want to write that as the answer, but we should be careful to check to see if they factor. If we could take out a common factor, we should then simplify it. So what does x squared minus 3x minus 28 factor to? Minus 7, x plus 4. And then x squared plus 9x plus 20, that's a little bit easier to factor. We have an x plus 4 and an x plus 5. Notice that the x plus 4's do reduce to 1 there. So we have x minus 7 over x plus 5. Last example, number 6. Number 6 is tricky for a lot of people. A lot of people will make a mistake with this one because they don't know what to do with the negatives that they see for the exponents. And so I got to make sure that you see this here. Oh, almost got them all, not quite. Okay, there we go. So in this situation, a lot of times people want to move this -1 down there, this -2 down there, this -2 up there. Everybody see that, why that's a temptation? The difference is if you had, say, 4x to the -1, y to the -2 over z, something like that, you can move those down in that situation because it's all written as multiplication. This is not all written as multiplication. It's written with addition and subtraction. So therefore, your option for taking care of this is to write it as follows. 4 minus 4 over x plus 1 over x squared. That's the top. The bottom is 4 minus 1 over x squared. That's the bottom. You see the difference between those two? When they're separated by addition and subtraction, you can't just drop them off back and forth. It doesn't work like that. So I've got 4 over 1 and 4 over 1. What's going to be the common denominator in the top? X squared. So I will multiply the top and bottom by x squared. In the middle, I'll multiply the top and bottom by x. And that gives me a 4x squared minus 4x plus 1 all over x squared. If you notice in the denominator, we should have a common denominator of x squared as well. And when I do that, I get 4x squared over x squared. Multiply by our reciprocal. Well, I'm sorry. What did I mess up on here, you guys? This piece should be 4x squared. It should be 4x squared minus 1, right? Sorry about that. Yes, sir.
I have a path.
Yes, sounds good. So I multiply by the reciprocal, x squared over 4x squared minus 1. Notice in this situation that the x squareds do cancel. And then we should be careful to just factor what's left over. Let's do the easier factoring first. Does 4x squared minus 1 factor? Difference of 2 squares, so it factors to what? 2x plus 1, 2x minus 1. And then if we look at 4x squared minus 4x plus 1, we're going to see if that factors. And it does. 2x times 2x is my 4x squared. 1 times 1 is 1. And these are both going to be subtraction signs. Notice that the 2x minus 1s, those will reduce. So you get 2x minus 1 over 2x plus 1. And that's that. Your assignment, there's problems 1 through 16. 1 through 12 are required. 13 through 16 are optional. (13 through 16 are optional. Some people might wonder, why would you do 13 through 16? Number one, if you feel like you need the extra practice, then go ahead and do it. The second reason why you might do 13 through 16, you might say, hey, right now Mr. Gentz's class is way too easy for me, and I would like a little bit more of a challenge. If that's the case, please look at 13 through 16. I do have today's answer key posted as well as yesterday's. Everything should be up here. You do have a good 16 minutes, which is more than the other classes get without a doubt. So go ahead and take some time, and I will come around and help you as you need.